Hello guys and gals, and welcome to this video on section 5.6D. This is the last section of 5.6, and so this video should be nice and short for us because this is not too crazy of an idea. Now, in the last sections, we were talking about reaction energy profiles. We were talking about the fact that bonds have potential energy in them, and we talked about the fact that a transition state occurs in the middle of an elementary reaction. That transition state is highly unstable, and it's actually the difference between the energy level of that transition state and the potential energy held in the reactants that makes up our activation energy. The difference between those two energy levels is our activation energy. Okay, so in 5.6D, we're going to look at something called the Arrhenius equation because it's going to help explain why why rate is dependent upon temperature, which of course is related to the activation energy, right? So, as we've said, nothing can change the activation energy. Not temperature, not concentration, nothing. But we do know that temperature can change the rate constant K. And we might know, or we might not, that K is related to the activation energy as well. And it's related to the activation energy through something called the Arrhenius equation. So the Arrhenius equation is here, where K is the rate constant, P is the fraction of collisions with the right orientation, Z is a constant value that's related to the frequency of collisions. E is just the mathematical constant. EA is the activation energy. R is the gas constant. And T is the temperature. So this is a pretty complex equation. It takes into account almost everything that's required for a reaction to occur and those things that affect the rate of the reaction. So it's very complex. But we don't really have to memorize it. We don't really have to solve anything with it. Solving for it is considered to be beyond the scope of this class. But what we do need to know is that because K is dependent upon rate, the rate is dependent upon temperature. Okay? So the Arrhenius equation accounts for the collisions needed to reach the transition state, right? Now, strictly speaking, because the activation energy doesn't change, we would really think that the rate should be pretty constant. Like, it might increase a little if we increase the temperature. But the Arrhenius equation is explaining to us why that because K is dependent upon the rate and the rate is dependent upon temperature, then K is dependent upon temperature. Okay? Hopefully that made sense. It's a little confusing. Basically, we just need to know what the Arrhenius equation tells us and all of the pieces that are related in that, okay? Let me know if you have any questions.